logic. In today's session, we are going to study about the Siemens S7 Simatic Manager. Okay, so Siemens is a very well-known brand when it comes to the PLC. So let's move on to the topic. Yes, so step 7 is the standard software package. Okay, so which is used for configuring and programming the Simatic PLC. That means Simatic means it's a Siemens brand. Okay, so it is used for configuring and programming the Siemens PLC, and it is a part of the Simatic industry software. And there are so many versions when it comes to the Simatic Manager. So you can see the version here, step 7 micro-DOS and step 7 micro-win, which are all for the simplest standalone application. Okay, that means you can make use of the controller like S7 200 series. Okay, the next one is Simatic S7 300, 400 or 1200. These are all the series of Simatic PLC, and it is used for the wider range of function, which may be the global data communication, configuring connection, opportunities of assigning parameters to function modules and communication processor. Like that, it is having a wide range of functions. Okay, and in this course, we are going to study about Simatic S7 series 300. Okay, so 300 is a CPU series. In that CPU series itself, we have another kind of series which is called as 313C. It is a CPU type. Okay, so in this course, we are going to study all the concepts and examples by using this series only. Fine. And Simatic S7 300 series is a modular PLC. So in the session 2, we have seen about the types of PLC, right? In that we have two types. One is integrated, another one is compact. So this integrated means what? Modular means what? All the components will be present as an individual slot. Okay, like that. 300 series is a modular type PLC where it will be having some rack. In that rack, you are going to keep all the components like power supply, CPU, IO modules, like that. You are going to keep all the components in a separate place. Okay, that's what it is, modular PLC. The third point is this CPU. This particular Siemens 300 series 313C CPU is having 24 DI, 16 DO inbuilt. Fine. So for example, for the required project, we are okay with this. We are more enough with this DI and DO and AI and AO means you can proceed with this CPU. Else, if you are in need of more DI or more IOs means you can go with the expansion modules. Fine. So these are all the inputs and output count which are all inbuilt in the CPU. Fine. And moreover, as like others, PLC has a range of individual CPU. Okay, differing in performance, installation, number and type of ports for connection of other device. Each CPU can be extended with other modules of individual digital input, output, analog signals and special modules, and moreover another one is communication interface. Okay, and here by using MPI cable they are making the communication. There are two type of cable. One is PPI, another one is MPI. PPI means point to point interface. MPI is multi-point interface. So by using MPI cable here we are going to make the communication. Fine. So that's it about the basic information about the 300 series. Fine. Now move on to the addressing part. So addressing is very important in PLC because it is used to represent the location of the input and output. So all the inputs and outputs, that may be a digital or analog, whatever it may be, it should have a proper address because that address we are going to represent in a ladder logic. In our previous session, we have used the example like X1 as a contact and Y1 as the coil. So X1 we need to give us some address. Same thing for coil also we need to give some address. If we are not giving the address means PLC is failed to detect the location of the IO. That is the main thing. So depends upon the data type only, here addressing is getting varied. So when we are talking about the data type, we are having bool, integer, word, double integer, double word and real. So these are all the main data types we are going to use in the ladder logic. So obviously bool means it is binary, it is going to take a single bit. But when come to integer, word, dint, dword, real, these are all for the analog IOs. So these are all the registers where we are going to store our analog values. So if you are talking about the integer, it is a 16 bit. It will take a 16 bit. So double integer will take 32 bit. Same word will take 16. Double word will take the 32 bit. And real, that is nothing but a floating point number, will take a 32 bit to store its value. Okay, so these are the basic idea about the addressing part. And in Siemens, how we are going to address the IOs. That is what we are going to see in the next slide. So let's see about the input addressing over here, right? So input addressing, for example, we have used that example in the previous one, no, X1 and Y1. So X1 is nothing but a one contact, that is one digital input. So for that we are going to give one address, means we will be taking this I0.0. Okay, so how here they are preferring the address means, here they are splitting the address with a channel. So each channel will have a 8 inputs. Okay, so here there are, if you count it, you will get the 8 inputs over here. Fine. So there are input addressing and output addressing also. So each channel will share the 8 bits. So for example, for one digital input, you will be taking a 1 bit. Fine. Suppose in your project, if you are having a 9 inputs you are going to use, means you will be taking I0.0 for your first input, second, third, fourth, fifth, sixth, seventh, eighth, and this one. So totally you are having a 9 inputs. You will be using a addressing like this. Fine. Same thing. I means here input. It is representing the input. Same, can you look out the output addressing? Here we are representing the output with a Q. Fine. Q0.0, Q0.1. So it is like a nothing but a bit. So on the whole, if you look into the all 8 bits is a one channel. That means 1 byte. 1 byte is a one channel. And in one channel we are having a 8 bits. So in one channel or in 1 byte we can take the address of 8 DIA. Okay, if you are looking at this, it will be 8 DO. Right? This is for digital IOs. Okay, the same thing we will be using memories obviously in our PLC. So if you are using a memory contact or coil, that will be the indicating as M0.0. Like that, here also per channel will have 8 bits. Fine. So how long it will go means, it will go up to 127 channel. All for input, output and memories for all, it will take up to 127 channels will be there. Fine. And these are all for the digital IOs. How about analog? How about the register address? For example, instead of bit, you are having an integer number. How we are going to store that? Obviously, integer will take a 16 bit, right? We have discussed in the previous slide. Integer will take 16 bit to store the value. So in that case, we will be referring that as MW0. And why I am not using MW1 means, since one channel is having 8 bit, integer will take 2 channel to store the 16 bit. That's what MW0 and MW1 will take a single integer. Fine. For the next integer, if you want to store means, that will go up to MW2 and MW3. Right. Now 32-bit input. That may be output also. Okay. For that we are going to use MD0. That means, see here the next 32-bit will be MD4. That means MD0, 1, 2, 3. So 4 channels will take the 32-bit. 4 8s are 32. That's what the concept is. Fine. So if you are representing the integer with the MW0, automatically it will take MW1 for that. Same here. For the 32-bit representation, if you are taking MD0, automatically it will take 0, 1, 2, 3. So 4 channel it will take to store the 32-bit. I hope you have understood the addressing part. Let's move on to the ladder logic program in the software. So here we are. Yes, so it is a Simatic manager. Once it get open, go for file, new. So it will be asking you to create a new project. I'm just giving. Just click OK. Since it is in a VMware, it is taking some time. Yeah, can you see here? The project we have created is here. So right click on that. Go for insert new object. So since we are going to study about the Simatic 300 station, click on Simatic 300 station. Yes, so it is created. Again, double click on that. It will take you to the hardware option. Again, double click on that. It will take you to the hardware configuration page. So in this place, can you see the slot and designation over here? So right click on that. Insert object. So again choose Simatic 300. In that select rack 300 and choose rail. We have already discussed that Simatic 300 is a rail type, modular type PLC. So modular means obviously it will be having the rail in the back, in a back plane. Okay. So here, see here. So here we are having 11 slots. So in the first slot usually it will be the power supply, right? So in the first slot usually it will be the power supply. So you can add here by double clicking or right clicking. Insert object. You can choose any power supply, whatever you are having. And the second slot obviously it will be your CPU. Go for insert object. You are going to see CPU 313 series, C series. You can choose any version. Since it is a simulation, you can go with any version. Yeah, so it is created now. Can you check it out here? When you chosen this 313C, obviously it is giving DI24, DO16, AI5, AO2. So it is listing out how many IOs it is having. Okay. One more step is pending, that is click on this DI24. It will take you to the property page. In this property page, go to address. Check out this system default, because here we need to give 0. It is an optional one only. For example, here if it is 124 is the default one. That means in your program you need to start your IO addressing will be like I124.0. For the next input I124.1. Like that you need to use. Okay. So I don't want that. I want to start with a 0. So if you give 0, automatically it will take 2. So totally 3 channels. Because 24 DI, right? 24 DI means it will be taking 3 channels. Same here, I am going to start output with a 0. So automatically it will take 2 channels. So click on OK. Same for analog also. I want to start with the continuation. Already we have used 3 channels for input. So here I am going to start with the 3. Here I'm going to start with the 2. Fine. So why I have given 3 is for the digital input I have used the first 3 channels. So the next one is started over here. The first 2 channels was used by the DO. So for analog output it should be started with the 2. That's it. That's it. Click on save and close this page. Yeah, fine. So see here your CPU is created here. Click on that. S7 program. Blocks. OB1. So organization block. So this is the main page of our ladder logic program. Double click on that. It will take you to the property page. Nothing need to do here. You just see here there are 3 languages we can write in this Simatic manager. I'm going to go with ladder. Just click OK. So it will take us to the programming page. Yeah, so this is our programming page. Here only we are going to write a program. In our previous session we have seen about this normally open, normally closed and coil contact, right? Let's see one small example here. In our course we are going to do the ladder logic by using a simulation method. So let's connect one simple program. The same thing we have discussed in the previous session. So this is a rail and this is a rung. Here only I am going to connect the component. So to get the component from this place to this place, click on this horizontal line or rung and click on this. So it will be coming. Okay. So for output, if you want, click on this, it will come here. So it is asking a question mark. That means I need to give the addressing. Okay. So I am going to give I0.0. Fine. And here it is Q0.0. Fine. So now I have connected one switch with one coil. So what will happen if I turn on? This fellow will need to on. Fine. So we are going to do the simulation. So go to Simatic Manager and open this simulation on off. If you want to see the output, you need to use this option. Click on this. It will take you to the simulation window. In this simulation window, you need to pick this option, Run P. Fine. Now move on to your programming page. Click on download and this one, monitor. So once you click on the monitor, your run option will be blinking. Fine. And here can you see the green color? That means power is coming over here and it is restricted by I0.0 because I0.0 I have not turned on yet. So how to turn on this in the simulation? By using the simulation window. So can you see here IB, QB and it is having the 8 check-in boxes. That means it is indicating the first channel. IB0 means it is the 0th channel. Fine. So this one is the I0.0 and this is the Q0.0. For example, here I have used the address called I0.7. I should use this one. Since I have used I0.0, I am going to turn on this. Can you see here? If I turn on, automatically Q0.0 is on. Even you can see the output here. Whenever I0.0 is on, Q0.0 is on. Okay. If I turn off, it is going off. I hope you have understood this concept. Let's try with the normally closed switch also. So to go back to the edit mode, click on this monitor on off and click here, change that to normally closed switch. I'm going to delete this I0.0. Fine. And I'm going to do the same thing. Download monitor. When I click on the monitor, automatically output is on. I have not touched the I0.0, right? Can you see here? I0.0 is not on, but still Q0.0 is on. Why it is mean? Because it is a normally closed switch. It is allowing the power supply to enter. That means it is getting the closed loop whenever we are going for the run mode. See here, if I disturb the switch, if I am going to open the switch, automatically It is not getting the closed loop, so output is off. Fine. So this is how we are going to write a program in the Siemens Simatic Manager software, and lot more concepts are about to come. Wait for the next session.